Hi guys, welcome to this tutorial. In this tutorial I'll be implementing KNN, K nearest neighbor, from scratch in Python. So let's get started with how KNN actually works. So assume we have some data, and this is how our data looks in two-dimensional. So these yellow dots are belonging to class A and purple dots are belonging to class B. Now assume we have a new point, which is a this red point, and we want to predict or we want to classify which class this red point belongs to. So how KNN works is first it requires a parameter k, like what is the value of k. Then what it will do, it will search k nearest points to that new point. Say this is the red point, is our new point, right? So it will search 3 for this. For k equal to 3, it will search 3 nearest points and check how many points are from class B and how many points are from class B, and it will check which class has more points in this when k is equal to 3, and whichever class has more points in that region, it will classify that red point to that particular class. Say k equal to 3, it will classify, in this k equal to 3, there are 3 points, 2 belonging to class B and 1 belonging to class A. So it will classify this red point to purple here. But so this is how our k algorithm works. But the point is, we have to check for different k values, because depending upon the data, k can work very small k value can work, but it can but for some data, for some other data, it cannot work, or it may be misguiding or misleading. Say for k equal to 6, k equal to 6, it has 4 yellow points, or points belonging to class A, and only 2 points belonging to class B. So for k equal to 6, it belongs to this. So it's better to check for different k values and then choose accordingly which k is working properly with that data which we are handling. So that's how KNN works. Let's get to the implementation part. So let's first import all the required libraries: NumPy, Pandas, sklearn is a library which has many pre-processing or post-processing, or also uh, many models, ML models already implemented. So from using this library, we can just use the function from this library and simply achieve that feat. And matplotlib is for plotting how the data looks, or graphs, etc. So this is, we imported our data. This function is calculating the distance between 2 points, say x1, x2 and y1, y2. So npid.linarc.norm will do square root of x1 minus x2 ka whole square plus y1 minus y2 whole square. So this is the Euclidean distance function. Now let's load the data. I am using iris data. I hope you guys have already seen this, but I'll show you. Yeah. So this is how iris data looks like. There are 4 features we are having: sepal length, sepal width, petal length, and petal width. And the species are our target or labels, like if this particular sample belongs to this species, etc. So we are having 4 features, and this is our target. So let's now split the data. So we are having these 5 columns, right? But these 4 columns are our features, and this column is our target. So let's split it into x and y. So x equal to this first column means all the rows or all the samples, and 1 colon 5 means as indexing in Python starts from 0, it will not include this. 1 to 5 means 1, 2, 3, 4, and this 5 is excluded. So we are having these 4 features in X and the 5th column in Y. So we have split the data into X and Y, and then our input and target, and then let's split it into split the data into test and train. In ML models or in general, we split the data to 80% in training and 20% in testing, so that we can know how our model is performing. So, and this train test split function is from sklearn, so we can just put X and Y and test sites. It will give X train, X test, Y train and Y test. Now this was our pre-processing. Now let's train our model. So let's for understanding, let's initially take k equal to 10 and the prediction. So this prediction array is just I'm just initializing the list where I'll be storing my predictions from test, X test, and correct count initialized as 0 to give my accuracy, like how well my model is working. So in KNN we don't need to train something, so we have X test and X train. So we'll see X train is the data which we are already having, and X test, the points in X test are our new points on which we'll be predicting like what could be the value, or predicting the class of that particular sample from X test. So we need a for loop on X test. So for I in range, len of X test. So I'm iterating over the samples in X test. Distances matrix initialized with empty list. You'll know what I'll do with this list. Now what we want to do is, we want to say we have that point X test, then we want to calculate the distance from that point to all the points in the training or the training set or the X train. So what we are doing is, distance equal to a numpy distance from this point. X test of I is our new point, and we are calculating distance from that point to all the points in the training set. Okay, so here this distance is the distance between X test of I to X test of J, and we are appending here. So in this list, appending, it will just include appending, it will just add the distances. So what I am appending here is first X train of J, what is the point, what is the sample and the distance with that sample, and Y train of J is what is the label of that particular sample. So if you see, I'll show you here. So this is how our distances is. So numpy array is our X train. This is the distance and this is the label that particular thing belongs to. Okay. Now what we want to do is, we want to sort this list with respect to the distances, because we want a nearest k points, right? From that X test of I, we want nearest k points from our X train dataset. So after this for loop, we'll sort this with respect to distances. So a distances is a list of lists with having 3 columns, or you can say a matrix with 3 columns. This is a matrix with 3 columns, 1, 2, 0, 1, 2. Okay. So so what this part is doing is, it is defining a lambda function in which I want to sort this particular list. So sort with respect to x of 1. X of 1 means that particular x of 1 column, which is distances. So x of 0 here will be this part of the list, x of 1 will be distances, and x of 2 will be our labels or targets. So but we want to sort this distance matrix with respect to distances. So this lambda function is being used. Now after this, we have our distances matrix as like this, and you can see this is sorted from distances 0.14, 0.17, 0.24, 0.24, 0.264, 0.264, and you can also see that particular point having label iris setosa and all. Okay, now we want to calculate, now we want to see how many k points, these, say k is equal to 10, right? So in these 10 points, which label occurred the most, and we want to classify that point with that particular label. So what we are doing is, first neighbor is equal to considering k closest points. So we are just removing other points and considering only top k points, that top 10 points here. Now class counter equal to counter. This function is to count how much time how much times the labels have appeared. So for neighbor in neighbors, so for each neighbor, I'll just increase the counter. So this is kind of a dictionary, you can say, where I'm increasing its value, how much time that have occurred. So if I show you how class counter looks like, yeah, so you can see key is iris setosa, and you can, this neighbor of 2 here is the labels white ring. So class counter of iris setosa plus equal to 1. So I'm just counting how much time that have occurred, and then I'm predicting accordingly, like which label has occurred the most. So this class counter dot most common will give us which label has occurred the most. So iris setosa has occurred the most. And then we can predict or we can assign that label to that particular point. So prediction dot, I'm just predicting here, prediction dot append. So as you can see, this is returning a list. So it's first item we need, and now this is a tuple, and we need this iris setosa. So again, it's first item we need. So 1 of 0 is giving iris setosa. So our prediction is iris setosa. Now if y-test, now I'm checking if it is actually the label or it is something else. So I'm checking if y-test of I double equal to prediction. If my prediction is correct, I'm increasing my count, and I'm doing these steps for all the points in the x-test, and then I'm calculating my accuracy, how many my predictions are correct and how many total points were there, and then I'm printing my accuracy. Now after this, here we only did for k equal to 10, but as we saw earlier with that example, that it's not necessary that for a particular k value it may work. So we need to check for different range of values for k for a data, because it depends upon the data how it is. So let's check for a range for k from 1 to 35. K equal to np dot arrange 1 to 35 will generate a list from of k with the value 1, 2, 3, 4, 5, 6 to till 35. It will exclude 35. That's why it will go till 35. So And this accuracy list is to store the accuracies for each k, so that we can interpret how it is behaving, how KNN is behaving for different values of k for our data, iris data. So let's start. It's just similar, but we just have to include one more for loop for k. So for for each k, we have to do the same process here, which we already did. So for each k, what we are doing again, predictions list, correct count for accuracies. For each x test point, we are calculating the distances, and then we are sorting the distances matrix, making a class counter to count how many times a particular label has occurred, and then predicting the most common label from our in the closest area, all the nearest k points, and then checking if our prediction is correct or not to give the accuracy. And then we are appending our accuracy for particular k value in accuracy list. Done. And then we have our accuracies list. So let's see, print accuracy. So you can see this is our accuracies for k equal to 1, with k equal to 2, with k equal to 3, 4, 5, 6, 7, 8, 9, 10. Now let's plot this accuracy graph with respect to our k values like 1 to 35. So we'll use matplotlib library, plt.plot. K is our x-axis. You can see 0 to 35. We have the list, right? K, this list is our x-axis, and y-axis is our accuracy. This list, and label is equal to testing data accuracy, which is mentioning here for ease so that people can understand. Then plt.legend is like printing this. So in x-axis it is k, and y-axis it is accuracy to show it out. And then plt.show to plot the graph. Now as you can see, with larger k values it is decreasing, the accuracy decreasing. And for larger k it may be possible because of the data imbalance. There are more points from class B rather than class A, and we are predicting class B. So from this plot we can say for iris data k from 5 to 10 is best, because we are having a constant accuracy of 1. So that's the KNN implementation with from scratch in Python. See, this is the whole implementation in Scratch. There is a one line code in sklearn which will do the whole process, which is KNN, k nearest neighbors. All what is required is the argument or parameter k. So even if we let's use this and see how it is behaving. So we have to import this library. So this is also behaving something like that. So 5 to 10, the best accuracy is there. So this sklearn library, inside it is doing the same stuff, but for ease of user we can just use a simple one line of code and perform KNN. So thanks for watching the video. If you have any questions you can comment, and also I have pasted the GitHub link to the repo, so GitHub link of the repo called KNN. So if you need code you can go there. Thanks again, stay safe.